I do have to make a very clear disclaimer that I came here as myself, as an individual. I do not represent my workplace. Neither can I, neither do I wish to. And I'd like to thank IKE, the Heartland Institute, and the CFAC friends for inviting us here. It is such an honor, actually, to be able to speak to you on a subject I guess I felt most passionate about, which is the question about how climate actually changed. So, without further ado, I guess I will pose the question. If we think that the sun is a big driver of the climate system, such that I precisely say that it's about solar warming and solar cooling, so where does the CO2 is hiding right now? I think that the story that you have heard this morning, and I'm very, very grateful for Professor Eworth and Poos for really making such a fine introduction about the subject of meteorology and the boundary between meteorology and climate, what does it mean, and so on and so forth. IPCC clearly is an anti-science body who attempts to try to hoodwink the rest of the world. And in fact, to put fear into a lot of people, to scare people in terms of what the climate could basically kill the planet if we don't stop all this human use of the fossil fuel. I beg to disagree, of course. So let me start by trying to ask a very simple question, which is often a very difficult thing, actually. If you think about how to teach a class about climate change, I mean, you clearly do have to make some effort to ask the simple question, what is climate? The figure there obviously is very busy. Most of the subject matter, I'm glad that the two professors has given some introduction, including soil moisture, evaporation. Those are all basically written by equation rather than empirical observation-based sort of issues. It will depend on clearly the horizontal wind and so on and so forth. And then, of course, you have the giant beast of the ocean, which actually kind of not quite appear even in this, somewhere here, the ocean flux. And then to really put the really foolish statement that this carbon dioxide is the only driver for the climate system, I say that we really should challenge this notion. And indeed, it's very, very wrong to try to keep going that path. So this is why, to have a short and a rather concise answer, perhaps we say that to try to understand what climate does and what is climate, you do require that many of discipline. In fact, I'm quite sure the list is completely inadequate. You will require astronomy, solar physics, geology, geochronology, geochemistry, sedimentology, tectonic, paleontology, paleoecology, glaciology, climatology, meteorology, oceanography, ecology, archaeology, and history.
Engineering.
That's right. Sorry, see? Please, we keep adding to it. So to say that it's all about carbon dioxide in the atmosphere, so just studying the features about what atmosphere is pushing, is highly misleading to say the least. This is why, as a matter of science, one should continue to try to be skeptical about this whole thing, and yet we really may not need IPCC at all, because IPCC also know a lot about this disagreement we have with them. But then I have another quiz for this. It's a rather interesting quote to me. Who could enumerate the countless changes that the atmosphere undergoes every day, from that predicted today and what the weather will be a month from, or even a year from now? It's a very interesting quote, actually. It turns out that it appears very long ago. It's by the Bernoulli's family, of course. Jacob Bernoulli is The Art of Conjecturing, and it's published 8 years after his death. But it is a beautiful book in that sense, but this element appears there, even the question on climate. So indeed, people have been thinking about these matters as weather and meteorology and climate as a problem of physics and mathematics for a long time, actually. And we are still yet to make some very serious breakthrough, although there are some good news because there are a few really good thinkers around the world is doing that. One of the premier one will be our friend, Professor Christopher Essex, who spoke at a meeting in Paris. So I'm proud to call him friend. That's all about it. Rub off his strength in mathematics and physics. So I would advise for anyone who want to go and catch these CO2 butterflies. So don't go around doing that and then proposing all this carbon capture, all these useless notions that actually doesn't help anybody except their own pocket. Now I'm going to put up this graph. but I'm going to use it in a very different way. You have seen it, yes? You have a bunch of climate models producing all these different outputs, and then you have quite a serious sets of observation from the balloon data sets, and then, of course, the satellite data sets, showing you that actually, as time goes forward, that your disagreement with the predicted warming, if you put carbon dioxide into the atmospheric model, or GCM, that you get a higher and higher discrepancy. I would say 9. Forget about all this. Because the question you must ask is that, what does the climate model actually do? Actually, it's somewhat embarrassing. The first point is that I do not want to force you to read this, but this is the kind of statement you can find. It took me about 2 months to find a statement like this because I wanted to find out what they actually do. How do they treat the cryosphere, the ice and the snow, in the, what you call the NASA Goddard Institute for Space Study model? What is actually quoted here is saying that essentially they have adjusted and tuned the climatology or the climate in their artificial climate in their model. Essentially, they have too much snow, up to 2 times more in the Antarctica, and then 3 times more in Greenland in terms of the snow accumulation. And then guess what they do? The following line is very interesting. We therefore choose to add the amount because, first of all, you have no mass balance. That is really very, very bad notion to talk about physics or science, okay? You have a completely artificial system, and then you keep adjusting it, and then they put this water into the ocean to balance the budget. That's so on and so forth. And I'm giving all the excuses about how it won't influence anything. But I just say that first, I really don't understand that kind of work. Then, if you think about what is actually known about climatology and weather, this is one of the latest results that was just recently published. Do focus on your left, the observation. This is actually cloud. It's a very nasty beast in the climate system that we need to understand. At least we now attempted to try to make some measurement. Here we are referring to low cloud, and we are referring to specific cloud property plotted in terms of the cloud reflectance and then cloud cover. So you can see there are certain class of distribution of low clouds. And then when you ask 2 of the best French climate models, you will see that it's like really shooting random answers. I mean, it's just all random. We're nowhere close for them to describe anything on the instantaneous level, let alone trying to find out what is the climatology, how does it change. So they're actually producing results that is completely, I guess, deviate from reality. Then really it's a very simple conclusion. In fact, it doesn't need any physics or mathematics. It's a matter of logic. Yes? Why would you want to believe in such a model? Then come from my areas of own expertise, which is about radiation, sun. You would see that if you have a collection of this model, you have many, many results like this to show. Of course, this is how the whole business or the whole enterprise of climate modeling has become highly embarrassing in my view. I wouldn't take a career in that because it's embarrassing. You know, you're not doing any science. You're simply, I don't know what you're doing, put it that way. I'm just confused by what they're doing. But what is actually measured is about 150. You can see most of them are overestimating the radiation incoming, solar radiation, at least to the surface. That means their hydrology is completely different, their rate of evaporation, latent heat problems. So no wonder, if you look at how you ask a simple question, let's pick the major monsoon, Indian monsoon region. And then you ask yourself, if we look carefully in terms of the Indian summer monsoon rainfall, June, July, August, and summer, and September, and then you ask what the CMIP tree, which is the previous version of this intercomparison climate project, right, all the models, where this is only plotting the differences. So they have more rainfall, they have less rainfall all over the place. Then the question is, I don't want to ask any question that I cannot answer. We do have a question that we can answer, which is, what would the most current generation of climate model do? It's really interesting. It's almost an exact plot if you look carefully. After 5 years, after so many years, the error is completely the same. I think we should quit now, we should stop funding this kind of work because it's embarrassing. It's not doing anything, right? Because I don't know exactly what you think that you can trust your model on precisely. So I will quote a statement from Professor Jagdish Shukla. He's from University of Maryland or Washington, somewhere in Washington, D.C., George Mason University. He made this statement that despite this million-folds of increase in computing power, enhanced ocean and observation since TOGA, which is one specific project in tropical Pacific, that you haven't improved anything in terms of ability to try to figure out what the climate will do next, which tells you how complex the problem is, and certain humility is certainly called for. And then to try to presume that the climate model, because we want to drive it with just one particular variables like atmospheric carbon dioxide, and then you can figure out the answer, and the answer mean anything, I tell you, God bless you, it's very bad. Then I want to make a very vivid picture about what does it mean when people started to talk about this ensemble averaging and so on and so forth about multiple model. I want to put out a quote by the way, it's also a very typical trend for people to use certain prestigious of people like Robert Kerr, Professor Robert Kerr, who's the Nobel Prize in Chemistry in 1996 for finding the phenomenon of buckyball, this C60 molecule, would come out and say a statement like that. Well, you know, this sobering conclusion from IPCC about future warming is based on elaborate model of the Earth. It is usually wise to be suspicious, he say, but then we're not talking about one scientist model, a number of programs give similar results. So let me give it a flavor to this idea that you can seriously average all these different models and then expect a miracle out of it. I would propose that we take an images and all your favorite jetliner that you like, okay? And then let's try to digitally average the images. And here's what you get. So what do you propose this averaging look like? I believe the analogy is very adequate. So indeed, you give me a faster computer, I'll give you a wrong result a lot sooner. I'm very proud to have a last name of Soon, of course, so it helps. Then I'm going to show a graph. I'm going to show a graph that is actually internally reported among all these people who is in the business of climate modeling. But then they never really want to publish such a thing because, you know, it's a bad thing, you know. Your funding may be cut after that. I want to ask you a question. Can you guys want to speculate? Okay, it's a plot of global temperature, okay? And it's marked with different color, but it's, you know, over 800 years. And then the difference between from beginning to the end is 1.8 degrees Celsius. And I'd like you guys to know is that, and then no climate forcing. You want to know what is the reason to cause these changes in the global temperature? It's merely a same generation of a climate model, but run on different computers, okay? The problem they have is enormous, actually. Here, I just introduced to you. Please don't forget numerical problem. They have so many numerical problems. If you start talking about precipitation, they got so many problems that not scale resolve, you know, climate don't have any cloud. No wonder they could never improve. And after all these 25 years of investment in quote-unquote solar science or meteorological science, all these people are wasting their money going to all these conferences, selling all this fear, and no one is doing any real work. I'm really sorry for that because I look at it. I actually went through this since 1991 until now. It's almost 25, 26 years to look at this problem. And it's such a mess. As a postdoc, I'm seriously very scared. Started as a postdoc. Now I'm a full-fledged scientist, of course. So it's highly embarrassing. So my short conclusion is garbage in, gospel out. People like to say garbage in, garbage out. I mean, if it's garbage out, why do you care? Garbage, throw it away. Right? It's the gospel that they give you that is very, very scary because the basis in which it come about is very, very bad, and then the statement they want to do is highly, highly dangerous. So I want to sell you some watermelon if you like. It's $1.49, okay? So please, maybe I should sell you for $149 million.
Excuse me, that wasn't a watermelon.
Thank you for being challenging. Yeah, you know, a skeptical mind would not sit around and just take it from them. Now I come to the point where I can share some very exciting result that we published just last month, November, in Earth Science Review. It's a work that is somewhat accidental because of all the crazy things that I do in this life to try to learn something about climate and the sun with no interest for money or fame and so on and so forth, is to meet scientists, people like you, that shares the passion to try to learn a little bit more about nature, that sort of thing. And these two are my favorite, Ronan and Michael Connolly. They're from Ireland. And what we did is that we somehow worked together and then produced something really, really exciting that I want to share with you. Professor Edward has tried to hint to you about this phenomenon of urban heat island effects. And many, many other issues, by the way. It's not only the urban heat island effect. You can put your thermometer near some places and then the trees start growing, so on and so forth. So all this sighting problem. And then when you measure the temperature, 2 times a day, noontime, that kind, and then you change your time of observation over time history. So Ronan Connolly and Michael Connolly and I have worked very carefully to try to look in what is available. So we start with very zero-order thing. By the way, I never make strong conclusions. I only try to tell you we attempted this approach like this. Professor Edward has his own approach. What we did is that we say, why don't we ask a simple question? Can we pick the rural station that we have and try to see what does the result tell us? By the way, you notice we try to escape the whole Europe, huge area. Because we have looked at it, we are still looking at it because that will be the next move. But we only want to know things that we know, the station history, so on and so forth, where we can really understand. Okay, every shift, every jump that it looks suspicious, because climate itself not only varies, it does have shift and non-shift. You know PDO phenomenon and so on. You need to be very clear about what is doing what. So we looked through that. We compiled this series of temperature data from rural China, rural USA, rural Ireland, and then Arctic Circle. Then we produced this Northern Hemisphere composite temperature, which is plotted here. The result is rather interesting, not because I seek certain answer, but the very obvious statement that I think is very interesting is, of course, I hope some of you know enough about the history, the temperature, Northern Hemisphere temperature that has been shown before. They always show that the 1930s and 40s is warm and then it goes down and then it zooms all the way up. But here we have the height of this temperature change around these two periods to be more or less similar, okay, indistinguishable at least to the level of our measurement uncertainties. So I want to ask the question, if we got such a result that is so different from IPCC, I would ask, what is the IPCC thermometer is actually trying to tell us? This is one of the results, which is from NASA GIS. That's why it's good to quote NASA GIS in the beginning. The hour curve should be compared with the red curve. I'm not even touching the southern hemisphere, another class of problem that you have to be very careful about. You can see, indeed, the 40 was much, much cooler compared to basically the, year 2000 to 2015 or so. It's a very curious thing. So I would propose, I'll make a hypothesis that what they're measuring is not related to actual climate change. What they're measuring is lumped under this thing called non-climatic related warming, which of course has to be corrected for. That's the whole idea. If you want to study the climate, how it varies, how it changes, you need to study things that is not related to, all these other artificial effects. So we went through the whole process and tried to do that. Then we gain some confidence. We say, okay, can we look anywhere else to try to find how does the information we produce different or can be compared with some knowledge? So the first thing we look at is basically the sea surface temperature over Northern Hemisphere that actually was produced by the United Kingdom Met Office that shows you the errors together with what they are measuring and show you that actually, it's not bad actually. This is somewhat of a surprise. People thought that the height was produced by the sea surface temperature. So urban heat island effect indeed is very real in the land surface temperature compared to the ocean, which you are not seeing it until, of course, they may adjust it someday later. Because the key person that produced this data record, John Kennedy, we have tried to correspond with him. He seems to be unhappy, but then he didn't make a very strong challenge to say that we are in error in quoting their results. Okay, so that's a bit of a good news. Hopefully data means something. And then we look at another set of data, which is the measure of glacial length. The distribution of the paleoproxies are here. And then we basically try to compare and see how well our Northern Hemisphere composite compared to this glacial length measure. So no matter what it is, this thing contains some information about this multi-decadal or centennial scale changes, which Professor Evert has actually explained to you about, the sunspot kind of a cycle, multi-scale changes, multi-time scale, including the 80, 100 years, 200 years time scale changes. So the result looks not so bad, so we gain a bit more confident. Then even tree rings, although tree ring is well known to not resolve multi-decadal changes very well, it has much what you call squish amplitude. The amplitude is a bit smaller, but it looks okay to me. Not so bad, all right? So again, right or wrong. It's okay. If it's wrong, it's wrong. Big deal, I'm not married to the data sets, it's just looking at it. So we should study it with very free mind, just only trying to see what more we can understand and do from here. Then when we test and do another test, we compare with so-called the CMIP5, the UN IPCC favorite product on Northern Hemisphere temperature. You can see it kind of don't do that well, okay? So you can draw any conclusion you wish. We did draw our conclusion. Our paper is quite large. It's almost like 40 pages in print. So please ask me if you are interested. And then during when we were sending around the preprint for people, and one of my colleagues from astronomy was asking me, how about the satellite data records? How come you're not showing any comparison? So this is a post hoc test. And I did put in the 2 satellite records to show you how it varies. The only reason you don't put that because the data length is so short, of course. This is the problem of climatology. We don't understand what climate means in terms of how long it is and so on and so forth. The data are really short. But we put all the information we have, so you have to have the internal consistency. We were not afraid of this test, of course, but I'm proud to tell you it's truly independent until this colleague of ours asked for the check. Then we come down to what does this mean? What does this record really mean? The picture I usually like to show is, of course, physical sizes, small. Earth is small, about 110 times smaller than the sun in size. But it's not about size that matters, it's about the energetics, right? The Earth doesn't produce any energy at all. This is why the fundamental problem of supplying energy to the climate system is all the sun, nothing else. We have a huge problem if we have an ice age, rather than actually overheat ourselves, because we can have an engineering solution to this problem. But when you have overheat yourself, when you cool, you really need a heat source somehow, which is really a difficult problem if people think seriously about how it works. So from that, we put in the best estimate of the solar irradiance. I don't say anything else except to explain to you that it looks interesting. So we would suggest that the hypothesis to try to reject the sun temperature connection is actually very difficult. The order is very difficult. Okay? That's about all you can do. What else is there to do? To tell you that I know everything about the climate system? No. So that's the way it ought to be. And I'm very proud to be able to come up with a result like this, by the way. So it's very interesting. Now I want to get into sun a little bit to try to explain to you why that particular irradiance history was chosen. Okay? I am lucky that I started by learning about sunspots and all that for a very long time already. I've been thinking about that quite a lot, actually. So, actually, I want to ask another question. Is there another way we can do this independent checking, how the irradiance modulate climate and climate dynamics? One of the questioners was saying about, the temperature gradient. In fact, that's the answer. This is what I did even earlier, but I quote Professor Richard Lindzen from MIT first. Okay. From Professor Richard Lindzen, which is trying to explain to you, this quote is very relevant. It says that most of the major climate changes are really related to how the equator to pole temperature changes. So throughout history, we know that it can be anywhere from 20 degrees to 60 degrees. It just so happened that at present time, it's about 40 degrees Celsius. So it is indeed, it's not the changes in the mean temperature. The mean temperature is actually only a byproduct of the changes of this equator to pole temperature gradient. So then that leads me to actually ask a very simple question. If we were to take this gridded temperature product, what does it look like? And then compute this so-called equator to pole temperature gradient. I did that work with Professor David Legates at University of Delaware. And here's our graph. It immediately tells you, especially the stuff that is going up at the upper end, it shows you now the present period is more or less indistinguishable from actually the warm period there. It shows you that it's very interesting. We thought that using that would get rid of the impact of the non-climatic features. So when I throw in my climate line, my estimate of the solar irradiance, it works again. And this paper has been published in 2013. I do make a very small note is that indeed we made the cutoff period to be included in the working group report. IPCC, of course, ignored it completely. That's the usual strategy, which is very unhealthy for them because eventually that bubble is gonna burst. So just the graph is the same result at the top but bottom, just to show you if you think that the CO2 could change the temperature gradient correctly. I doubt it. And then now we come back to the part to explain why that particular solar irradiance that we use. This is a bit of a trick for people who care about the sun or love to study the sun. It's among the very few early photograph of the sun, actually. So it's taken about 1873 at Harvard College Observatory. And as you all know, I am not famous in terms of my scientific work, but I'm more famous in terms of my association of able to receive some money for funding to do some of my work to support my family, regardless of who gave it to me, including Greenpeace. Of course, they never give me. So there's all this huge amount of attacks on me in New York Times, so on and so forth. And then we have this current director of NASA, Gates, who came out in public saying about I basically even have a fallacy named after me. And then all my work are very, very pointless, okay? And then of course, it's okay. You know, people should say anything they want to say, but it better be correct, actually, when you went so public and say those things. Therefore, I wish that people would tape this and then show it to him. And I would like to debate him in public, actually, under any circumstances. So the way he thinks that I'm such a cheat and such a bad guy is because I actually produced a paper like this at the top, which is a measure of the Arctic surface temperature. I think one of the presenters showed that. And then the irradiance is the same irradiance that I've been using. And then he said that the irradiance should be the line below. Oh, so therefore, I am cheating. Okay? That's fine. But here's my answer now. If you haven't heard of it, I think it's worth listening. And then there is another so-called solar expert, which is true. They have some training in solar physics. I am not ignorant. That's the whole point. I may be very, very stupid, but I'm not ignorant. And I'm not evil in that sense, between just to show you results that agree. No such thing. So they have produced that. They say, oh, Willie's stuff is all crazy. So, you know, he's so bad that he wants to do this. Now I wanted to show you on your left is basically my chosen solar irradiance record is on your left. And then there are a bunch other that exist. These are all of them that is published. Okay? So the challenge from Gavin Schmidt is that I chose to use that results and then I'm ignoring all of this. Okay? So my answer to that is that, well, I really think that the one on the top left by Hoyt and Sharton plus update is actually very good. It has much more physical reasoning than the rest of it that's being produced this day by IPCC. Okay, so Gavin Schmidt chose that, I use this one. One of the first check is that when you plot those irradiance that they produce, actually I knew those problems, but you could not stop these people. They did nothing but just simple scaling with the sunspot record. I profoundly disagree with that attitude and that sort of approach to science. That actually is a bit of a voodoo science. Because the dynamics of this sun is a very complex one. We may have a set of equation, we don't even know what the solution is going to be. It's a coupling of Navier-Stokes plus Maxwell equation. It's a very hard problem. And then to try to talk about this sunspot and then turn in, like I say, you may think that you understand solar activity, that very strange term, that the sun's its magnetism changes. But it's very, very hard to do this radiation, how much it changed, modulated by. And I am lucky that because we have studied sun-like star, a copy of group of sun that look like the sun, that we are able to put the physical constraint on how large or how small the thing is. And we know that it doesn't need to be 0.1, 0.2%. It can be anywhere from 0.2 to about 0.6% changes from modern minimum to present time. That's why we prefer that sort of observation-based constraint, okay? Oops. Go back. Yeah, but I wanted to tell you that sunspot activity is merely a very rough proxy of the total solar irradiance, or even so-called SSI, which is in different wavelengths, spectral irradiance. But they do not represent the whole story. So any other things that I can bring forward to show you, I mean, the example of how complex sunspot group is if you look carefully, there are so many features that actually up to 60 of them, you have to classify into 60 different groups. And we don't have that kind of information to discuss and reject something. For example, the Hoyt and Sharton result should be wrong. And then the other one should be preferred. But I have to tell you, it's highly suspicious when all of them is merely just a scale up of the sunspot number series, which is clearly tell you that something is not right. And then the reason also I show the sunspot is I tell you the size matter. Here is an example to show you that there is circular modulation of the solar activity. If you look in terms of sunspot area, that is so small, actually the smaller than 100 in that units. 169 units is actually about the size of the Earth. These are very small, tiny spots. And it shows you that from the Royal Greenwich Observatory daily photograph, that shows you that there are some very serious long-term modulation of the behavior, especially at the peak of 20s and 40s, okay? Which is something that I think they should not neglect with this kind of information. It's been known for a long time, actually. And this paper just happened to be published in 2013, not so old, but we knew this sort of thing. And this is the basis that Douglas Hoyt and Sutton came up with their result by explaining that if you look at this number called the fraction of sunspot, right, it has a very clear dynamics and topology by itself. So in the inner part, you have this umbra, which is dark magnetic region. That few line there is very vertical. And then you have the side called the penumbra, is coming at an angle. So if you study that ratio, you actually is changing quite a bit. And the way they deduce this is that a 0.8% change in the convective velocity from the bottom to the near surface will correspond roughly to 0.4% change in the irradiance. That's how they came out with their results. And as far as I'm concerned, no one has ever sort of showed this in public or even say that this is completely should be ignored and rejected. There's no way. I mean, the evidence is there. You can't erase it. So a few more slides, I'll be more or less done, to show you that there are additional ways to look at this issue, that you have this long-term, longer than 11-year sunspot cycle. That's why sunspot cycle is not everything at all. One of the things to look at it is actually solar equatorial rotation, because the magnetic sum of the sun is related to how rotation is coupled with the convection activity, right? So one of them, it shows you that it does have some very unique changes in the early 20s or so. Then looking at rotation rate of the sun, you can also deduce some information from there. We show you that you don't have just the sun that is really just following sunspot cycle. In fact, it is a manifestation of all this complex physics. So I would more or less end by saying that it is really not so much that these people have refused to acknowledge the existence of the long-scale TSI variation, which actually why we're using the result. But rather, they really gone out their way to find the reason to dismiss the evidence that support these things. So this is what you call, that kind of bias should not be allowed in scientific discussion. I think I'm done here. Thank you for your time. Thank you.